I think we've quorumed up. Yeah, hi, this is Coffee Compiler Club. I'm here to talk about compilers, language runtimes, garbage collection, locks and unlocks, and somebody wants to talk about pre and post condition variants and whether they should panic or assert or whatever. Anything to do with language implementations and runtimes. You're live, you're being recorded. If you don't like that, bail out. I reserve the right to moderate, never had to do it. Everyone here has heard this spiel a dozen times over, so done, go. So I'm going to start because I have a rant that came around yesterday. So I'm here doing some consulting for a company doing alternative SQL-like query, declarative query language. So they've got they're implementing using Julia. Okay, fine. So you know, in theory, there's an LLVM behind, and you're writing reasonable-looking Julia code. And so I'm here looking at TCPH numbers, a lot of times stuck in doing SQL-like queries on fixed strings. This is like not a regex. This is like a wildcard and constant string. So they've got some generic, completely, you know, Julia implemented, nice job, regex. I said, okay, wait, let me just swap this out for a stupid string scan. Okay, that's much, much slower. And I'm like, nah, that doesn't make any sense. The regex can't cheat anyway. I'm doing Boyer-Moore. It can't possibly do any better. So why is it like half speed? And so I sit down and carefully write the Julia in a standalone thing with a big old pile of code, big old pile of test case. So I get some performance numbers, you know, a million passes through on 1,000 random strings. Way slower than regex. So I write it in Java. Oh, 10 times faster in Java. So the Java version is like 10 times faster than the Julia, identical line for line piece of code doing a Boyer-Moore. Boyer-Moore minus minus, it's a stupid thing. It's not much more than a string scan. Followed by still 4 times faster than the regex from Julia, which is kind of expected. So what the hell is LLVM doing that strings suck by 10x over the plain old Java version? So I got some Julia experts and we went round and round and round and round. And then it turns out that I claim that Julia has made a number of poor design decisions that lead to surprises in performance in places where you don't expect it. One of them is globals only ever get totally generic type. So a global array of strings is unknown to the typing system, basically. So if you pass a global array of strings, it's passing a global array of I don't know what, and he does a full virtual call breakdown, no class hierarchy analysis or nothing on the code that's running it. Why? So we sorted that one, and it suffices entirely to pass it as a parameter arg, and he specializes, than to load it out of global memory. So that was surprising. Like, what the hell, guys? You can't type global memory like same as instances? This is like identical. So the next thing, so I got some performance back. So the next thing was, you know, profiling, and it's all about range checks everywhere. Can I not turn off the range checks? So eventually I turned off the range checks. Life got better, still way the hell worse than Java with no range checks. Now Java's running with range checks. So like 3 times worse than Java. It's getting, you know, more reasonable. It's down from 10x worse, 3x worse. Finally sort out Julia strings are blended UTF-8 and ASCII, and the standard array accessor on a string, which looks really sweet for doing character by character math, right? It's just like that. That does a Unicode-aware indexing operation, which requires a trip of 1 to 4 to count characters for every index thing, whatever. And of course, it's just abysmal. And it wouldn't hoist. I had loop invariant string. I had, you know, string scanning where one of the characters I'm scanning for is constant in the loop because I just said, you know, pattern of index, and it wouldn't hoist the invariant out because, of course, under the hood, it's a freaking loop. So I claim that if you do array-like syntax, you should, you know, by default, give array-like performance guarantees. And if you want to have a Unicode-like behavior on your strings, it should be typed as a different kind of string. This is like Python does this. They have like U string versus C string versus str. one of them would have the flavor of it's an array of characters, and one of them has a flavor of it's Unicode, and we all love Unicode, and Unicode does fun stuff, but it's not the fastest thing on the planet. And Julia hit it all and said, no, str does the right thing, except that it doesn't by a factor of 10. So that's why I rant on Julia and choice of string, how you represent strings. I think these days you actually do need to have two versions of strings, one that does byte math only and is expected to run really fast and will cover the ASCII set, and we'll cover the Unicode set if you do no interpretation and you're just slamming bytes around. And then there's a Unicode aware version, which, you know, people want kind of names and addresses and stuff in Unicode.
It's dramatically worse than that too, because Unicode is code points, not glyphs. So you can end up, if I remember correctly, the longest glyph is like 11 or 12 Unicode characters.
Oh God.
Right. So
Julia has this fun experience where if you ask for the indexes are byte offsets, but they're only valid where you're at a code point. And so if you ask for a byte index in the middle and it's not at the start of a code point, it throws an exception.
Right.
What the hell?
Right, because it looks for the 1, 0 on the front of the...
What's the design model choice here? I'm just like so confused. So every data set on the planet from the pre-90s, every header of every database, I'm doing, you know, SQL shit, every XML keyword and or pattern, whatever, these are all ASCII strings and they just show up by the billions. And okay, I'm done ranting on Julia. I claim they made the wrong choice. It's not the choice I would have made. I could be kinder. It's not the choice I would have made.
So why are global variables always generic in Julia? Is that because they are mutable?
Why are globals? I tried hard to make it an immutable global.
No, but why? So you mentioned that the problem is that global variables in Julia are given a very generic type, so you have dynamic dispatches all the time.
Yes. I don't know why.
Is it because
they have a final assignment. I busily, you know, I said test data equals array of fixed strings, you know, and you did whatever you did for final assignment and you were done. And I'm like, okay. And they were like, nope, you're unspecialized in any way. So maybe they are mutable and I can't make it final and he just decides he has no type info. He doesn't even give it a type info. Like I was not allowed to assign the variable a type. That's part of the, they give you a warning about it when you go look up global variables. You cannot give a global variable a type. So I couldn't say test data is array of string. Not allowed.
Well, I will say that the fact that you're using the term global variable is an instant turnoff for the language altogether. So leave it at that.
I was writing a 10-line micro benchmark. I just wanted to slam down a big ass pile of data that I cut and paste out of a TCPH dump. And I don't know, fine.
And in the original thing you got from the customer, they were also doing it with the global?
No. The customer was running the TCPH query sort of legit. I did profiling, declared there's a regex showing on the profile that should not show on the profile. How can I fix this? So I promptly put a bunch of prints in to discover that the query in question was in fact a dumbass non-regex string, and this was the norm, and in fact required for this particular language spec. Like the SQL query does a like, which is a non-SQL string search, non-regex string search. So I said, great, capture the strings that come through, throw them in a file, and I'll just write a better string search, faster one, see what the hell happens, right? So the customer was actually getting the data from a database. And the strings are however the strings came out of the database, and they're a bunch of random junky, some cut and paste bad text and some auto-generated variations of medium, burnished, anodined, copper, whatever things they have that they auto-generate. So no, the customer data wasn't in a global. I was me, I threw it in a global and thought nothing of it, and was very surprised to discover that globals have no type in Julia.
But the character indexing, that was impacting the actual real use case?
I'm sorry, say again?
So you described the two things that made the 10x difference and the
The
indexing
stir array of
into
index
the string.
Yeah, the stir array of index I put up there, that is a standard type string. So if I say circle,
I was just curious if in the customer's case they were also being hit by that, or that was again just
no, they were not. So in the customer's case, I saw the regex. The regex drops down to some carefully handcrafted thing in the libraries, and I couldn't tell you if it went to hand roll assembly or not, but the regex did the right thing for the string. And he had a bunch of casts going into the regex because the regex demanded a known string, and he did all his hard work after he'd casted it to a string. So I claim the global issue was not biting the client. Although in this particular TCPH query, the regex was showing up as like 40% of one of the queries and 10s and 20% on several other queries. So I thought, okay, why is there a regex here? I don't believe there's a regex. I went looking at the query. Sure enough, there's no regex. And so we shouldn't be using a regex for a non-regex query, and because it should be, knock on plastic, should be faster. So I wrote something that I claimed should have been a lot faster, and lo and behold, it was a lot slower. And I was like, what the hell? So I wrote a micro benchmark. Well, the micro benchmark bit me for the global, but then it bit me also because you can't do efficient string math in the obvious way. You can do the string math that's like you would expect out of
iterator or something.
But it looks like this. My first line of stir of index, you say code unit, unannotated. It's coming from the base library, taking a string and an index. So like you smack your code with the ugly one, and suddenly you get the performance back. I mean, it's a dozen lines of code. I can throw up what I wrote. It was not hard.
And so that only works for ASCII?
Yeah, totally. This is TCPH. It's like benchmark from the 70s. There's only ASCII characters here. The like query specifically says, I only do ASCII. Right. You're using the SQL like command, you are only doing ASCII.
Yeah, when I've had to deal with this stuff before, what I do on the constructor for the string is verify that it's all ASCII, and if it is, then you just choose a different implementation.
But you store the ASCII-ness of the string with the string or not?
Yeah, of course, yeah.
So there's a bit in the string header that says I'm an ASCII.
Or a different class altogether, yeah.
Or a different class. What's I'm asking? So you change class, or you just runtime compute on the fly? That's a very interesting choice. That's interesting. At H2O,
yeah, because you're gonna take the indirection for a lot of things anyway, so you might as well take it up front.
Yeah, but I'm asking, you do it as a typing system, or is it a runtime test? Is runtime test as a type, or is a runtime test as a bit?
Runtime picks a different string implementation depending on the data.
Yeah, but how does he look at the data? Does he scan it every time? Here's a megabyte of string. Do you scan it to decide which implementation? That's already one pass over the string.
You're asking if it's compile time or not, right?
Yeah, right. Or is it strongly typed at compile time? Or is it a runtime, one time you walk the bit thing instead of bit?
Yeah, if it's constant data, it's compile time, sure.
But is it, if I hand you a generic string that you pulled off a file, and then...
Yeah, then it has to check at runtime. Yeah.
Yes, but now is it turned into a type? This string is typed as an ASCII string, which is what Python would do.
That's
right.
I
want a U string or a C string.
Right.
Or is it a bit in the header that you set that said, I walked it once lazily and discovered it was ASCII?
The way I modeled it before was the former, where it would actually pick a class based on the data.
So it's construction time.
Right.
So you had a string factory maker that did it. Yeah, okay, fine. Which is what we did at H2O. Most of the strings were all ASCII, 99.9%. So we had a special slow path for people who wanted to have non-ASCII strings, but 99.9% of everyone did
right.
ASCII only, and we fast path that stuff. Yeah, totally. Okay, but you did it at string, which is what H2O did actually, honestly. We didn't have typing for the data because we stored it in big compressed arrays, but the effect was string construction time we chose. Oh, another person piling in. Okay, well, maybe I've done beating on strings. So I was just confused at Julia performance, and we eventually sorted it out. And I have a version which is at least in Julia is at least tying the regex. If I turn off array checks, it beats Java, and if I leave them on, it loses to Java, but by 20%, not by 10x. Well, and I haven't actually finished out Boyer-Moore, so I'll do a real Boyer-Moore and see if I get see if I beat the regex by a handy amount now.
So maybe I missed the initial part. Why are you working with Julia again?
Oh, I have a client who's implementing a SQL replacement. He wants to take on the SQLs in the world, and he's heavily funded, big money funding it. So this is not a small operation. And they've got a relational.ai. They've got a, I don't know, it's more of a relational based or set based language style. It's declarative, not imperative. And, you know, you define queries and they have them, the answer set, and you can change the data or you change the query and they go get the data. And it's a real database. With a query language, it's not SQL, but they have to compare themselves to every SQL on the planet. So the claim is it's easier to write because it's not SQL syntax, and it's because it's really mathematically like relational set-based syntax or notions. But then they have to compare against TCPH. So they write their funny language doing the identical query that TCPH does, and they run it through all their query optimizer, and they bake it down, they go to their backend, they go evaluate the query on the data. Turns out, lo and behold, regex shows up on the performance profiles. And what the hell is that about?
Wait, so but why does Julia enter the picture? Did they implement their database in Julia?
They're implementing the whole thing in Julia, yes. Right, exactly. That was my, I go, okay, you know, you hoist yourself in your own petard, that's fine. I don't know enough about Julia to say yay or nay. I know it uses LLVM, maybe, you know, could work, fine.
But lots of funding, you say. Well,
they have, if you're interested, I'll give you a connection. They're always looking to hire quality people. I gave them my standard rate. They didn't blink an eye. So I'm making good money. Seriously, if you're interested, let me know. Actually, anyone here, they're looking for compiler people, language runtime implementation people. Anyone here who's, you know, excited about an alternative, and they do everything remote, obviously, in the modern era. Here you go, COVID everywhere. So shoot me an email or a text or whatever you want, and I'll make a connection. It's fine. That and reasonably sane. I haven't talked to a whole lot of people, but reasonably sane folks. So don't necessarily know if they'll actually win the war, but they're making a solid go of it.
Snowflake hasn't done badly.
Exactly. Well, this is a Snowflake follow-on. This is the same guys that did Snowflake are like, okay, we're going to win up again. Like I said, they got money. If you look at Snowflake's exit, they got some money. All right. Oh, there's an interesting fail.
And just what the world needs is another SQL database.
Yeah, they would smack you about for saying that. We are not SQL. And that infects their, you know, their entire claim to fame here. Yeah, okay, that was my rant. The other thing somebody put on a chat, my was Matt. Somebody put on a Twitter, YouTube chat about pre and post conditions and asserts, and should they panic or should they warn? I don't know. If no one's gonna say on that one, I'll rant a little bit and then, you know.
Well, Matt's on. Was it Matt you said?
Well, I'll go look it up again. Matt's not saying anything. We'll find it again. I had it a second ago and I closed the tab.
I think with like pre and post conditions, I mean, I think it depends on the language. Like if you have, you know, your average language making them panic or, you know, use abandonment, basically, I think might be a bit too extreme.
Mike Brown, not a person who's here.
And then that's primarily because the compiler wouldn't be able to do anything of that at compile time. But if your language has some sort of support for not gradual typing, dependent typing,
types,
then I think it makes sense to well, then you end up with a hybrid. We basically say, when we know the types at compile time, we use compile time checks, and otherwise we fall back to runtime checks. But
I thought pre and
I think
post
the thing with-
conditions were more generic. It's like,
right, and that's where I think, because I would imagine them to actually fail once in a while, even in a well-written program. So that's where you probably want to use something like exceptions or whatever it is.
well, that was, yeah, it was, the question was panic or not to panic.
Well, so I think of like, let's say post condition, let's say your language doesn't have different integer types. So it's just a single one int. There could be a use case where somebody provides a library with differently sized integers that rely on these pre and or post conditions.
But if a condition fails, is it like an assert that it's going to stop you, or is it some warning? I don't.
So I think that depends on the language, right? Let's say you have this library, so you have like an int 8 type, whatever. If the language doesn't have any degree of dependent typing, I think it will be less painful to use essentially runtime catchable errors, whether those are exceptions or result types, doesn't matter. Because I think in that case, the chance of failure is quite common.
But you're
and there's
expecting
case
to recover. So
yeah, basically.
my usual thought on pre and post conditions is you blow one of those, that's an unrecoverable error.
Right, and I would say both are totally fine. But I think if you make them unrecoverable, because they're sort of an integral part of the type system at that point, it kind of feels like wasted effort when you introduce that, but don't have any compile time checking whatsoever.
No,
Even for
okay.
simple cases.
I would claim a pre-composed, well, fine, I don't know. I'm thinking a pre-composed condition like an assert. I turn them on for debugging. I turn them off for performance. I'm expecting them to pass. If they fail, I have a bug. That's a hard fail. I have no recovery. Separately, there's a version that says I have a library that's efficient for this type. I have a fallback library that's less efficient for that type. If I fail a type check, I fall back to the backup plan. That's part of my runtime cost model. I'm going to run this test every time I know it, and I'm going to choose plan A or plan B according to the types. One is the program has no recovery. I don't know what to do. There's a bug. One is I have a fast and slow, or I have alternative choices. And I claim those should be thought about in different ways. And one I would claim is a pre-composed condition, it's correctness, and one is like nothing to do with correctness. It's a performance thing, and that's just that one. I want to have an if you pass, go left, go right according to the performance model, and one is I have no recovery in mind if this fails. You handed me an unsorted array in my binary search. I am not interested in trying to correct. I'm just going to die.
Yeah, but one person's panic is another person's exception.
Well, that was the question. This gets into, do you abandon or do you try to recover? And that's a whole different conversation, which is, we touched last time some. I'm happy to touch it again. That's like, some of these things are, no, my crash and burn, fix your bug. And some are like, I'm a server, I'm running somebody else's arbitrary junk code. I don't trust it. I want to catch everything they do and not drop the server down, but blow out some recoverable section. And so I declare where is the recovery point? You have a model which says I have a fairly well-known recovery point. And you can hierarchy layer them in. I think that's a great model for that version. I don't know whether you would call that panic or an exception or whatever. If I don't have a solid recovery plan, I guess that's the fail for Java. He throws exceptions all the time when there's typically no solid recovery plan, except at a very high level at what you would call like a service or a container, I guess a container. And Java does not have a notion of a container, so you have to hand roll a container to have a recovery model.
Correct. Which is actually somewhat reasonable in that if you're not rolling a container, then any assertion acts as a panic in that it'll stop the JVM itself.
This is a Herb Sutter document. All right.
Herb Sutter, the guy who single-handedly tried to make C++ not suck.
He did a lot of good stuff. He did a lot of interesting stuff for sure.
Yes, a far more organized mind than a certain Swede.
Yeah, I'm not. I'm not gonna go there.
I think worth adding there. Like I considered using preconditions because inspired by Midori's error model, they had that too, I believe. I opted against it. One, because it's opinions differ on what the approach should be, abandonment or something you can catch.
Yeah.
And two, I believe that the error messages it will produce will never be useful because you end up with this fairly compact syntax for saying, hey, I have a division function and we require that the value we're dividing by must be positive. Similar to most languages that provide an assert statement of some sort, the error message is usually something like the assertion and then the chunk of code failed.
Right.
And that doesn't really tell you why it failed, what the data was, etc. And so I opted just not to include it and basically require people that if they have some sort of check, they have to do it themselves, and then they can provide the error message themselves with, whatever additional data they want to add.
I certainly find it, I want to say, both convenient and telling to have asserts. Like I heavily assert code. And if I think there's something exciting about recovering a rare condition, I'll put it in the print function, or otherwise I take the default print. And the usual story, of course, is I'm running in the debugger and the assert gets caught in the debugger and I don't care for any print. I just want the stack trace and everything in the debugger. If I'm doing asserts on at runtime of complicated stuff and they're triggering rarely, then I change them to include the exciting print.
It's a shame that a compiler couldn't do that automatically.
I know, and they didn't.
Does it make sense to push some of that onto the programmer and be like, look,
well, that's what it
you
did.
can do a throwing assert or a panicking assert or a, hey, compiler, if you can't actually remove this assert when you're doing the build, blow up at build time, this is a, you must be able to prove this every time.
That's one.
And those are just three different concepts.
Right, that's what I'm strongly in favor of. A version of an assert that is really, it's a compile time fail. The compiler can't remove it. But then there's the flavor of panic versus exception. I kind of don't care because I usually treat an assert as a panic, and I'm not intending to catch it. So therefore, I'm going to let the debugger catch it. Fine. If it was somebody who was going to catch it and recover it, it doesn't make any sense to have it be an assert. Built-in unreachable. Oh, yes, a nicer syntax.
I think at the end of the day, this kind of comes down to like how much time you're willing to spend on the sort of ergonomics of this. Like a lot of people, when they add assertions to the language or library, it's the standard one where it displays some generic error message, maybe include the code, that's it. And I think if you put quite some effort into that, you can do things like automatically start a debugger or maybe display the values of local variables, stuff like that.
Include the stack trace in the error message, but you normally get that if you throw an exception.
Right.
So I think you get the stack trace if you just let the exception boil out the top and blow you down, which is fine for my Jenkins continuous integration nightly run blah 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 thing.
Right. Yeah, I'm thinking. So let's say the division by 0 one is simple because if that fails, oh wait, it can't be 0. That's the only possible case of failure. I think perhaps a slightly less obvious case is you have some sort of precondition on the user object that says, hey, the age must be above 18. Probably that's going to be some sort of assertion, like assert age greater than 18 or something like that. If that fails, they're not 18, but it might be nice to know, okay, what age are they actually? Because maybe that's minus 500 and there's some bug somewhere else.
Right. So stack trace isn't enough because it doesn't give you contents of member variables, and you've just blown out by doing a load of a member variable.
I think that, it really depends on the the coding question. if you have a piece of code where you look at it and you don't have to look at associated functions or whatever to figure out what it's doing, I think a stack trace is probably enough. But if it's some sort of let's say a mathematical expression where it's a bunch of different things, you're adding, dividing, multiplying, a bunch, etc.
Yeah, I threw an assert in there with a couple different things, but I'm pointing out member variables not being part of the assert stack trace.
Right.
Well, it's not part of the stack trace. It should be part of the rendered message for the assertion.
But it should be part of the message, right?
Yeah, we do that automatically.
Do you? You pick out all the parts? You throw the whole expression out, but you break it down, or?
We show the assertion that we actually De Morgan it first. So if it's a complex assertion, we only show you which part of the assertion failed.
That's actually really nice.
Yeah, well, it's really easy, actually. That was...
Well, yeah, but I have all kind of complicated assertions to say and.
Right.
And it's the fifth one down that blew, and I have to go to the debugger and break it down. Fine. No, I like that. That's a cool hack.
And then we show which variables contributed what values to the assertion. And what the compiler does is it basically goes to the expression tree and says, hey, I'm collecting interesting stuff. If you're interesting, put yourself in here.
Right.
And so it walks the AST, and variables based on type and whatever else will choose. Variables and sub-expressions can choose to place themselves in that interesting list.
Yeah, declare themselves interesting. Now, that's a really cool hack. Okay, I like that one.
How does an object self decide if it's interesting?
Not at runtime. No, it's a compiler decision. So the object has nothing to do with it. It's a passive.
But it's the type of the object, right? Oh no, you're talking about the language, the structure of the expression.
Right. Here, while you're talking, I'll go find a piece of code.
Look at my example in chat, and
yeah.
The under length fields both want to come out.
So it would show you the x._len value and the re._len value, but it probably wouldn't show you the contents of either x or re.
Right. Okay. Fine. Yeah, that's kind of what I expected. I think that would make a huge difference already. Certainly, if you look at Java's array index out of bounds exceptions, they take the index and the array length as a smart, but that was some hand rolled by a person. It was not done by a compiler. Yeah, throw out more examples maybe, but that was that in your De Morgan hack sounds like really cool. One of the annoying things that I end up backward slice. Yes, exactly, Matt, a backward slice. And by the way, your Herb Sutter paper looks really good. I only got halfway through here. I'll have to read it later. But he'd done a good job as to breaking out why we care. I have the funny thing where I always fail. Well, that doesn't help here. I have a very specific issue. I have lattice theory. A is a B and it fails. Well, A is a compound type and B is a compound type, and the top layer of the 15 pieces, one is busted, and you go down that one piece and it's another compound type, and it's compound types 5 layers down, and I have to find each slice.
Yeah, I'll show you the.
I need a slicing operation.
I can show you the De Morgan stuff if you want me to share.
Well, I'm happy to. I pretty much know what's going on with it, or I think I have a clue what's going on with it here. I'm sorting out my own head what I want to do with this concept of assertions doing slicing, both for language and for what I'm coding in Java right now. I just want asserts that blow out with a better slice.
Yeah, so many years ago when Java was still young, one of the base handy things we had was called trace. So you'd say trace x, and at runtime it would say x equals blah. And what it would do is actually when it hit that code, it would look up the source code. It would find the source code from the class name, and actually parse the source code for the variable name based on the stack trace and show you the value. So So it goes way back, the concept. Obviously, with the assert, when you write the compiler, it's a lot more efficient than a trace.
Yeah.
But back when we were doing that, we didn't have debuggers because there were no working debuggers for Java in '96.
Oh God, I remember that. Fine. You got to start somewhere.
Oh yeah, no, frick. I mean, it's amazing what they did, how fast it matured. But back then, printf was the only. What was it? Printf? What the heck is it called?
System.out.println
was the only debugger we had.
But
yeah.
One of the first things I always do is I end up with a 1 or 2 letter class name that has a 1-letter function.p. So it's aa.p as my, short debugging hack, because I end up debugging, and this is just a different thing. I end up debugging a lot of things where the debugger fails, and I have to have print functions because the debugger just doesn't do it.
I just turned Clippy on, and the editor says, it looks like you're trying to print something out. Would you like me to?
Oh, and have them splam it out? Yeah, I could probably do that now. There's a way to make that happen. I bet there's a thing. IntelliJ has a button somewhere if I hunt it up that says.
Joking about the old Microsoft Word assistant.
I totally remember.
The Clippy thing. It looks like you're writing a suicide note. Do you need some help?
Yeah. Yeah. Well, I'm happy to see Clippy died. It was pretty freaking annoying. I don't know, Microsoft went through wave after wave of complete failure on reasonable user interface things. It's just ludicrous. All right, pre-post conditions, panics, exceptions. What else? Julia performance. Let's do something. Rust Clippy? No.
Yeah, it's a thing.
We're trying to get serious here.
It's basically just a set of lints that sort of hook into the Rust compiler.
It's called Clippy.
And it's horribly pedantic. Like, it honors the name in every sense.
Well, you've seen find bugs, right? I don't know, it's got a real name to it now. This is Bill Pugh's version for Java that finds things that are blatantly wrong, which on a large code base, it always finds things that are typically truly blatantly wrong. It's always shocking to run it on any large database, a large code base. What would be no? Show me some junk out of it. Allowed you not? Yeah. Minimum version. Okay, now I wanted to see some of his what he annoys on. Fine, he is lint. Okay, lint I can understand the use of, right? Clippy is just funny for the name. So can I get a no? I can't get any examples. Fine, I'll drag it up. D Morgan, let's see. This is just you walking your AST though, breaking it down. Do you, when you say De Morgan here, Cameron, you doing top level? You're either separated by ands or ors, or how far down do you go?
Yeah, just the simple stuff. It doesn't try to rewrite it in entirety, but it basically breaks the ands into, because of short circuit ands anyway, it just breaks them into multiple asserts for all practical purposes.
Okay. Oh, when you implement the assert itself, you actually, because I just done the expression and then taken the end result of the expression, and then
right.
fail
but
path.
I want to break it down so that it's as if they were multiple asserts, because then I can show you which part failed.
Okay, fine. I was thinking your cleverness was on the fail path, the exception message got smart. But on the go forwards flow path with no failure, you just have an expression. You throw it to optimizer does what it does and cleans it out. Except that you still want to grab the AST to break it down to get the pieces parsed out and do something clever on the off path. I have to think about that. That's an interesting point. Right. Okay, fine. Yeah, I guess I'm seeing. So in the land of Java, we had this notion of an off path, de-optimized to the interpreter or any kind of slow path. And the fast path was only ever no best possible performance, no exceptions. But you had to carry alive what was necessary for any off path bailout. And then you go to the off path and you could do whatever the hell you wanted. And you could be slow in the off path. And that would be where I would have thrown the smarts to pick out what I wanted to pick out and show the error message as a complicated thing. The complicated pile of code to go break out the error message. And here's your rendering of the entry stuff. So I'll go stare here. Select traceable expressions. Right. Somewhere in here has got a vcall that you're saying you self-vote in or out.
That's right. And so basically it just revisits the nodes in the AST. And if there's anything there, then I,
Yeah.
something equals something equals something, right?
Yeah, so here's your SB.append. So I use string builder, but I have an SB class that is a string builder class base, but all the things like append are all 1 character long.
All right, this is Java code here.
Right, so I'm replacing Java string builder with an SB class with 1 character thing so I can append in line shortly. Followed by, has indent support, and it has, the other fun one, it has the uncar, which peels back 1 character. So I can say for I equals collection something and append a thing dot append a comma. This is totally what you got going on here.
Well, what I was thinking was kind of the other extreme. It was either Yorick or Trolls was talking earlier, and I thought they were doing such a great job at explaining. What I really wanted to do was like capture the video, and then when the assertion occurred, I'd put the video up. So I'd have to somehow encode the video into the executable. And no, I'm not joking.
Video.
It's actually what I was thinking.
This was the I'm doing video.
Right, wouldn't that be great? Like you hit an assertion and up pops Cliff Click and says, the problem here is that you were thinking you were using a 1-based index, so you're actually off by 1. Go take a look at this line. And
Well, I know Rust will sometimes link you to the documentation in the error messages, and it'll be like, you made the borrow checker angry. Click here to give an explanation of the way in which you made the borrow checker angry.
right, but it'd be far more impressive to actually encode the video into the executable. Then have
I think you need to go with a little
explain it.
animation then.
You
Just a
could
little like
you
3D
know,
animation of Cliff, and it could be Cliffy.
No, we're not going there. We are not going there.
You can also just ship an entire browser in it, and then your video is just an HTML video that you can link to. Just here's my programming language. It's 300 megabytes for just the executable.
So I threw out a little thing where I'm using uncar to peel off the extra comma at the end. That's just a cheap hack you can do with string builders. Yeah, video of where you screwed up. There's only a few places I would claim that there's a screw up here, but one of them would be Julia's string decision. The other one would be, I detect you have Gradle in your build system. There's your bug. Fine. Yeah, I love your assert hack there. That's I'm gonna have to put that in what I'm doing here. That's the better answer.
Well, the other one that we did, which is kind of similar, but it has to do, and the idea came, I want to say Kotlin guy was showing me something, and I liked it so much I grabbed some of it. But with a string literal, if you preface it with a $, you could say like x equals curly x, and then that actually renders as if you had written a minor program there, right? Like a new string buffer with a particular size estimated based on that, append an x equals, append the value.
I've seen people do this stuff.
Right, that kind of thing, exactly.
Yeah. I threw that in my spec, no implementation, but I threw it in my spec as this looks like a cool hack.
Yes,
Somehow you have an escapee character, whether it's $sign or percent or whatever, and then you go to full-on expression evaluation. You flip out of string mode, you do expression evaluation at the end of an expression, then you flip back to strings.
so what amazed me is the entire implement. Well, and I'll share one other thing in a minute, but the entire thing was like 4 hours of work, start to finish. And the reason is because when you're in the lexer, if you can identify that it's this mode, which you can when you hit the $sign quote, what you actually do is you recurse the lexer. So at this point, you basically go into a mode where the lexer, you create a new lexer for inside the quotes, right?
Oh, this is like the val.
And it's emitting a sequence of tokens to the outside lexer, which then collects the sequence of tokens, wraps them as a token, and says, here's your literal. So you have a token literal that when you look inside it is a sequence of tokens that then the compiler then produces from that the necessary code. I don't know if that made sense.
It was pretty close, but I'm not sure what your semantics are by your line then. I wrote a line which is simply parse an expression nested inside a string and just do a string append to insert it. And I'm not certain but it doesn't assign. Just what I wrote would return a string, which was as a string, x equals whatever the value of the variable called x was. That was okay. And in your case, are you talking the same thing? Or are you saying I'm actually assigning x a new value?
No. In this case, and then there are a couple other handy things. So first of all, we have an expression which we call a. So you have in ASTs, you often have expression statements.
Yeah.
Which allows you to take, say, a function call and use it like you can just say foo, and that's a statement. But it's a statement that contains one of a predefined number of expression types. So an expression statement can contain a function call, a blah. And that's really important in things like C, because in C and Java, as a side effect of that, an assignment is actually an expression, not a statement. So if you say x equals y, that's an expression that then gets wrapped as an expression statement. But what we do is in addition to that, we have what's called a statement expression, right? So I can literally say open curly. I could say x equals open curly, and then I can now write code here, right? Like all sorts of code here. And then later just say, return 3, right? And close curly. And so that x equals 3. So it's like putting a lambda in line and then invoking it. And so what you end up with the combination of that and the string interpolation is you can actually end up with something like, so you have a $sign quote, which goes into the evaluation mode of the string.
Start point, and then you're saying inside the curlies.
Then you could say x equals and put the curlies, and then inside the curlies you can put a second set of curlies, and now you're like back to this is arbitrary code that returns a value, right? And the cool thing about that then is that inside the string expression, there's a new variable that's defined using so there's a variable called $sign, which is the string buffer. Well, we call it an append.
You hand.
So now inside the double curlies, you can actually use, but the reason why it's so important is that if you nest something, you don't actually have to, I don't create a string buffer for each nesting. I can just end up, I think, appending to the outer one, something like that.
Does this have to be literal, or if I say $sign and then some string, will it eval that string?
You have to have the one curly starts the eval mode. The second curly is I'm in eval mode, so I'm just doing normal evaluation, and an open curly starts an arbitrary long expression.
Actually, it's a statement block.
Statement block. Starts with statement block. Yeah. For me, everything is an expression, no exceptions. So you can put expressions or you put expressions, and expressions do whatever the hell you want, including everything. or no disallowed things.
Right. But the best thing about this style, which I like I said, I think it's Kotlin where I first saw this, so credit that. But the best thing about it is that you stop doing that whole plus of strings together.
Yeah, that was kind of clunky.
Yeah, it's ugly. So
Java's done that forever, and like I said, yeah, it's kind of clunky.
So basically, anytime now that I'm finding a plus on a string, it's usually a code smell.
Yeah, I can buy that. Yeah, I haven't decided how I want syntax to go here. You basically said $equal, $quote is a syntactic form for a string that has somewhere in the middle allows, like this, somewhere allows finding an open curly and then
Right.
you switch
Bingo.
to, and that's different from a standard string, which won't do this evaluation hack.
Correct.
Furthermore, that string is, well, it's obviously syntactically a string. It's a constant right there on the spot, obviously.
And I assume Flavio's earlier comment is because in Scala you can pick what the escaping is or something like that. There's all sorts of I think
interpolation. Yeah, what do you mean by custom interpolation?
Yeah, so Scala allows, can you hear me?
Yeah.
Yes.
Yeah. So there's, you can define classes where the default parsing has like some rules on how the variables are spliced. So you have like a pattern for how to actually have like some codes within the string. But you can also define custom interpolations. Let me send you a link. So basically you can define a class and you can have like, for instance, an interpolation of a JSON string or something like that. If you go to this page, there's advanced usage. There's an example of like how you could create an interpolation for JSON.
So when you say changing interpolation to be, for instance, JSON, the scope of this is within some class. Whenever a string appears, it does JSON interpolation, or?
It's how, so at the start of the string, you put the interpolation that you're going to use. For instance, like if you go to that advanced usage from that link.
How is that different from just somebody writes a function call that says parse me as JSON and takes a string?
It's basically the infrastructure. The interpolation is happening there, and you basically get like the parts of the string that you are fixed, and then you get the values as well when there's something that's spliced like as a value in the string.
So that's a format string. So that's your F quote instead of a $, quote. That's a Python format string, which does the interpolation at the curlies again, right? Which is pretty much what, Cameron, what you were doing.
Yeah, it'll eval pretty much anything inside a curly.
Right, right. I guess yeah, throw a link out there, Flavio.
I sent a link with the string interpolation documentation.
Oh, there it goes.
Yeah, there's if you go to advanced usage, there's an example where you create they create a JSON helper for interpolation, and there's like some explanation on how the desugaring happens. It's very interesting. I've used this kind of interpolation for many things.
So in this advanced case, give me some JSON as me saying, "How's JSON?" Or no, JSON quote. Oh, I see, but JSON quote without parens. The $name and $ID, those, what are they, what's the scope on those? The outer class here?
Yeah, it's the scope of the expression, basically.
Okay.
And you can.
That's just standard string quoting going on. But then once you're done with the JSON quote, you further take that string and convert it into a JSON object.
Yeah, basically the Scala mechanism is going to give you who is implementing the parts that are
I see. Here's
the string and the values that were spliced.
Doing it, which is essentially, right, essentially takes the constant string bits out and just throws it into a builder thing. He does optimize it down into a better way. He doesn't actually build the whole fat string and then parse it. He actually hands the pieces parsed out to a JSON helper.
Yeah, and you can have blocks within the string as well. You can have $sign and then open a block and have arbitrary code there as well.
Oh, no, he does make a big string eventually, and he claims he could be more sophisticated. Yeah, that's fair enough. There's an way to optimize it, obviously. Huh.
Yeah, I mean, like performance is not really the goal. Like Scala doesn't like do a good
No,
job
I
at
get it.
performance,
It's
but
convenience.
yeah, more convenience.
Yeah. Yeah, with you missed my rant on Julia strings. They did it for convenience, but the basic raw string operations slowed down such that a standard sort of string scanning loop was 10 times slower than the Java version.
Wow.
And so I claim that they made a poor design choice on how they decided what to do with strings, such that a kind of standard usage was 10 times slower than what you'd expect.
Wow. Yeah.
And here, all these
I've
marked
never
strings are all
seen,
fine. It goes
yeah.
slow as they're going to go. Sorry. Yeah.
I will
Yeah,
say
I've never
with
seen-
format strings having code in them, you do have to be a little bit careful. Like Django had a number of bugs where as you were going through layers of middleware, it would format string and then format string again, and user errors would get interpreted as formatting templates. So like you could put arbitrary code into the content type and it would be like unrecognized content type. And then that would go through the string format on the string format side. And you can put arbitrary code to run in the servers in your content type.
Okay, so let me ask the question on this Python expression that they're clearly evaluating A, B, and C as, you know, in a local context. So they're variables and they get a value and they're going to do string concat in theory. When do A, B, and C get evaluated? Prior to any of the string concat or the middle of partially string concating? So replace here, I'll write the replacement expression here. F quote A equals blah, blah, blah. In quote, comma, B equals, lookup. I'm doing this wrong here. I have a very simple question and I'm making it complicated. Okay, so here I have, you know, A gets, divide by 0, throw an exception, and B gets lookup. So, you know, you throw an exception before you begin any string concatenation? Or if I reverse the order of A and B, do I do the lookup, then throw an exception? Do I have a partial string computed or not? What's the order going on here?
I believe you'll hit the divide by 0, throw an exception, and never get to calling lookup.
Okay, so he basically breaks out all the expressions, pre-evaluates them all, and then so the next thing, you know, I can get worse because it's Python here.
It should be the same as if you call a function with multiple parameters in it and it's working its way down the parameter list and it's going to explode whenever it explodes.
Seems reasonable.
Okay, fine. Yeah, right. Yeah. I was
Left to right.
I get I don't have my quotes and my curlies correct here. Something like this. So can I do something like this where I make a new variable in one of these and use it in a minute later?
No, I don't think you can declare new variables inside format strings.
Okay. But so there's a scoping rule in each of these little widgets. It's not the outer scope. So if I do an assignment of a variable inside the format, what order do you know, and somebody throws an exception. So I have like 5 of these things in a row, all of them throw assignments and some of them throw exceptions. What order am I guaranteed to have the assignments appear before the exception stops the evaluation? Is it standard left to right, the obvious thing?
Hope so.
On the spot, drill them right now. Okay, fine. But they're evaluated in the current context, so side effects are allowed. So this is more to Cameron. This is what you're expecting. Side effects are allowed. Okay. And it's just
in ASCII is the evaluation not the evaluation, the interpretation at compile time. I can't like pass a dynamic string in and have it evaluated, right?
No.
It's not a val. There is an eval separately, or there could be an eval separately. This is not a val. Okay.
Yeah, to do an eval, we would actually have to inject a compiler, create a container, and fairly expensive.
You have to have a compiler lying around somewhere. Yeah.
Well, we actually now have
like it minimizes the attack surface, right? There's no injection in attack then.
Right. And the way ASCII is designed is that we want people to be able to produce code on the fly and execute it. But because it's containerized, they can't hurt anything outside of their container, so they can be as stupid as they want. But originally what we said is we wanted, your top hacker to be able to share a machine with someone running their payroll and not have to worry about it.
Yeah, yeah. But there you're using a container to catch death as opposed to just lexical scoping.
Well, specifically to introduce code, you have to create a container.
Yeah, fine. Okay. Yes.
Because that's the big difference between, like, say, Java, where it's like, oh, I accidentally found this file on disk, I'll load it as a class.
Right. Right.
Oops. So the type system is just morphing on the accident of finding code, which is.
Well, it's definitely not an accident, but people try hard to make it so they can have a break it scenario.
Right. And then you accidentally used a library that used a library that used a library, and then,
Right.
And yeah.
Yeah. Well, there was an effort made to do security with scoping, and no one bothers because it was ridiculous. Fine. Except the VM has to.
That was JSR1, right? The real-time Java spec or something?
Not the real time. No. The security domains. That was such a pain in the neck, and it does impact performance, and no one uses it because it's such a pain in the neck.
Yeah. No one also uses the, what is the security manager gets turned off by everyone because it's about a 30% hit. So
that's what I meant. Sorry. Security manager.
Oh, right.
Domains were the thing the manager worked on. But if you have the manager, he puts lines in the stack for every possible crossing point, and that kills the compiler's chance to do any kind of optimization. Yeah. There's coulda, shoulda, woulda been a better way.
Well, it's actually a really good implementation that they did with the security manager circa 2010 or so. They really fleshed out the.
Oh, really? It was after I left then.
Starting with they were starting with a tough design that had been retrofitted on top of a no design. So it was quite an amount of work. And that was during the whole thing where the Java security was a huge topic in the industry. And, but yeah, I mean, the security manager is actually brilliantly good. It's just, you take a 30% hit and nobody wants it. So everyone turns it off, which kind of defeats the purpose.
Yeah, right. I know why the old security manager caused issues for performance and no one used it, but I don't know what the new one causes performance issues for.
I don't recall.
Yeah.
But it is amazingly good in terms of its kind of transitive closure capability from a security point of view. It's really an impressive piece of work. I would hate to have had to write it myself. So.
And then have no one use it. Yeah, fine. And I'm looking at the Scala thing again. They also allow printf style formatting with percents after you do the expression evaluation, which honestly, that's an interesting design choice too. Like convert it to string or follow with a percent. I guess you default to a %s if you don't have a percent following. Fine.
Yeah, and it's interesting because it's just like a regular implementation, like the user could do like the F interpolator. It's also a class that has a regular implementation.
Oh, and so because type safe, he puts the correct % formatting option by default if you don't actually throw one in, but you don't have to throw one in. Oh no, they should be followed by an example. Oh, okay. I claim if you're type safe, you don't need to have a following % if you can detect the end of the expression. How do you detect the end of the expression? First time it's a reasonable, like all parens have to balance. But if I do an F expression like this, I'm going to use Scala F expression here. I'm looking right at the example. Here's not the right one. So am I computing height plus weight? Or am I computing height as a string and putting the constant string plus weight following it? And how does it?
If you have expressions, you need to use brackets.
Okay, fine. So in the absence of a bracket, that interprets as plus weight is a string.
Yeah.
Just ends at height. And okay, fine. Yeah. So if I do $1 to begin, and then I throw a bracket in, which I could do the same thing. Now I'm an arbitrary expression land doing whatever the hell you can put in a bracket. Yep. And then it balances at the end of the bracket. Okay, that's fair.
Yeah, another thing that's very interesting, you can use macros, and the strings are known at compile time, right? The constant parts of the string.
Yeah.
So you can do the transformation, the interpolation at compile time as well through macros. It's very interesting.
So the prior conversation we had earlier was we want an assert that says this thing is known at compile time, and one of the ones that I want is exactly the same thing you just said, which is I will guarantee you, or I demand a guarantee that this thing is a compile time constant. But the compiler is doing, for me, it's doing aggressive partial evaluation, so I can go pretty far with compile time constants. But it must be a compile time constant because, for instance, in your case, you're going to take that string and then run it through the compiler. It's camera saying run through the lexer again. You nest the lexer and go again, and it has to be done right then and there.
Yeah. Yep. And with Scala macros, you can do these kind of things. And Scala 3 has a new macro system that is very interesting. So basically, it's a mechanism for users to define beta reduction at compile time. So you can force things to be constant at compile time. It's very interesting.
Right. Where I am at is something similar. Everything is partially evaluated at compile time to the maximum limit, which means everything beta reduces and all known constants fold immediately and all that kind of stuff. As far as I can carry them through with partial evaluation. They're probably
what do you do when you can't? I'm doing actually something similar. The problem for me is basically when things becomes too polymorphic, I have to have a limit somehow. What do you do when you hit like a limit? You have something that's you can't evaluate at compile time.
Well, I stop and I stop at that point and say, this is what I have now, and then it better type check as it stands. So I'm doing this as part of type checking, which is maybe a little oddly different. Some of the things I do, I will code expand to let me get more precision on types, typically for primitives, so I can bottom out at primitives. Otherwise, I'm doing full-on partial evaluation, which stops when you have unknown values that you read from disk or read in the input or whatever you get from standard in. I got an unknown value. I can't partial evaluate. Okay, that flows. That poison flows to being it didn't evaluate anymore. So I have to live with it what it is. So then if I arrive at one of your format strings with this string, which is somewhat partially evaluated, but didn't boil it all the way down to a constant string, I would blow up at that time and say, my F quote has to have a constant string, not an expression, because I'm going to invoke the compiler on it. And the compiler would say, the result of string concat is not a string, it's a function call, right? I didn't say that right, but basically I can't hand that to the parser at that time.
I think something interesting that Scala does, and I'm trying to do as well, is this new macro system in Scala 3. You might be interested in looking at it. Basically, you can give this kind of mechanisms to the users to implement things, so you don't need to bake in this kind of logic in the language itself.
Right. I mean, my goal was to let you, I guess, bake in the right stuff that you would bake into logic, like write macros and have them fold up completely and then turn into something you ran right there.
I have a completely different opinion on the topic, which is macros are evil, but it's not an opinion shared by many people.
No, I'm with you. Macros are evil. I did C for many, many years. Macros, I can do cool shit with them, but they're kind of evil.
Well, in C, I think macros are necessary.
Necessary, but kind of evil. Yes, totally.
It should be used only when there's no other choice.
Which is usually most of the time.
Right. So pound include is a macro, and you kind of have to have it. I did a couple other things with macros in Hotspot C2, where the name of every possible node in the graph is a list in a file that gets macro expanded in 3 or 4 different places to do basic construction of the internals of the compiler. So there are uses for it, definitely, but yeah, pain in the neck.
Yeah, and as we know, C++ for its first 15 years of life was just a macro.
It was just a big macro. Yeah, I remember that. So my goal with what AA is doing with partial evaluation is to not require macros, but to get that effect.
How will you guarantee that? Because the nice thing about macros is that they have a pretty simple operational model performance-wise, but partial evaluation, that's compiler magic.
So, make sure we're doing the right terms here. I think this partial evaluation is the right thing. My partial evaluator is basically a full optimizer. So it does whatever the optimizer does. If I can't fold your piles of strings and concatenations of strings into a constant string, then I'm going to blow on you. But if it folds down to a constant string, and it happens while I'm parsing, if it folds down to a constant string while I'm parsing, then when I come to the f quote macro or f quote function, he would stop, and would be a parser special form, and the parser would stop and say, is the result of everything up to this point look like a string? Fine, go to town. So he would stop at the f sharp or f quote, pull out what he thought was the string text for the expression, go evaluate that better goddamn cook down to a string. And if it doesn't, he's going to blow. And if it did, he's done. He's got a string, and he'll go recursively parse on it. Does that make some sense?
Yeah,
we need examples here, right?
Yeah, and that's why I mentioned the new Scala 3 macro system, Cliff. You might be
Throw the link out. Is it in here?
Yeah, I can find a good link for you. I don't have it handy.
Right, I'm not going to put a macro interpreter in, but I want to believe that what I'm doing will give me a similar effect, which I don't.
Yeah, and that's my point. I think if you do something similar to what Scala 3 is doing, that is basically allowing the user to force compile time beta reduction, is enough flexibility to have a very powerful macro system that is hygienic and doesn't have like most of the issues that macros normally have.
Right, I am right. I am not doing macros, but I'm doing arbitrary evaluation, including inlining of things while I'm parsing. And I don't have an example off the top of my head. If you write an example, I can step you through what I'm going to do with it. Like the F ones are actually, that one's sort of arbitrarily easy because it's easy to peel out the string expression. And then the string expression you peel out, you just hand back to the parser as a string. You got to guarantee you get a string there. So that's not a good example. I don't have the assert that this folded to a constant in so many things, but if you do I can make this a little better here. So somebody comes along and says, I want to make a call to a file system read on Windows versus BSD versus I don't know what. And the arguments are different between them and illegal on the other platform, but the function call names would otherwise be the same. I'm not doing this very well here. Actually, I could probably do an even better example. Then if OS type evaluates to a constant, I'll constant fold and throw away at parse time the wrong side of the if, which will just disappear off the planet. So I can do this way. Where args1, args2 are tuples, and I'm just handing a tuple off to OS read, but the tuples malformed on one side or the other, and I can strongly type that. And
So in Scala 3, you basically could define the OS type as an inline value.
Yeah.
And that's like the new macro system. And then when you do an if condition, you can also say this if condition is inline. I don't like the naming, but it's the mechanism they created.
Right.
That's going to basically make the if condition expand at compile time to a specific branch.
Right. And for me, if OS type evaluates to a constant while I'm running it through the parser, I'll inline it on the spot because I have limited amounts of inlining, and now I don't know how much I want to do, but that'll turn into a constant, which will turn into constant folding of the next piece at the parse time. Now, what I'm missing is a way to say you have guaranteed been inlined to a constant, and you must keep, hey, see ya. You must keep inlining until I tell you to stop, because I have to have this fold to a constant. So right now I'm just heuristically saying, hey, this looks like a thing I ought to inline because it evaluates to a constant. Well, there's a bunch of rules, but small size is one of them. And what the macro thing would basically say, must inline, like a keyword here says must inline because I need to have the constant, because it's going to be syntactically or type incorrect on the wrong branch.
Yeah, one of the decisions we made is that there are two forms of a constant, and one is a compile time constant, and the other is a link time constant. And the reason that we made that decision is because there are a number of boundaries beyond which constant evaluation shouldn't propagate. Otherwise, you end up with potential versioning discontinuities. So, say for example, there's a debug flag in a library that you're using, and you're making a decision based on that. If one version of that library has it true and the other one has it false, it shouldn't matter which one you compiled against. It should matter which one you're running against, but the value is still a constant. And so that's a link time constant. While if it's in your own library, if it's in your own code and it's true or false, well then yeah, it's a compile time constant and you can grab it. So that the
Java thing said all global static finals are going to get evaluated at CL init time and then be treated as a constant by the compiler when you're compiling against that after the CL init's run, which is how asserts get run in Java. They are literally load the debug flag on a class and test it and evaluate or don't, and the compiler then constant folds it away.
Right, but Java doesn't let you switch on constants that it can't inline at compile time, for example.
I'm not sure what you mean by that. You're not a constant if you're flipping it on the fly.
What I'm saying is
load time it is evaluated, not at link
the
time.
compiler makes a decision, which is either that's a constant and I can use it. Say I'm using switch as an example. I can use it in a switch statement, or it's not a constant and I can't use it in a switch statement. So if it's sitting on the other side of a library line, it's either taking the compile time value of that or refusing to compile. And if it takes the compile time value of that, you're broken if the version
you mean
changes.
For a case arm of a
Use
switch.
it a case label.
Yep.
Case
That's
label.
for
Okay, yeah. No, so, right. So we're talking two different things here. So Java has a notion of things that will turn into a constant for case labels for which the evaluation mechanism is extremely limited. You have to be raw numbers, declared static final raw number, and there's a couple of
or a string.
Or a string. It's really limited, right? The thing I'm talking about is the way assertions are done. He reads a static final global, which was evaluated entirely arbitrarily at class load time, class link time, if you will, or init time, class init time. Post class init, it is now considered a compile time constant for all future compiles. And that flag, that value can then be loaded and tested. It is tested in asserts and used to turn on or off asserts at class load time.
Right.
But it cannot be used as a case label. It can be used as a switch, which might compile time away, but it cannot be used as a case label.
Yeah.
And what I'm trying to do here with my stuff is declare that you could be a case label with what I'm doing with AA, as long as I can arbitrarily boil you down. I don't have a limit on how far arbitrary goes. I don't guarantee you forward progress, except I tell you it goes pretty damn far, but there's no guarantee, and that it needs to have a guarantee. I haven't sorted that one out. So you were saying link time constant. Yeah, it's similar to class load.
Right.
Oh.
So the idea is that you're basically, instead of encoding the value of the constant, you're encoding a reference to it, which then forces the errors that could otherwise be identified at compile time to be handled at link time.
Right.
Because it crosses a library boundary. So you basically verified all the information I have at compile time says this is a constant. I just can't tell you exactly what the value is because it's beyond my closure from a.
And then how do you implement a switch statement then with a value you don't have? You make a dynamic system that you're going to load a value in at some point.
Right. So the value is symbolic, if you will, at the pre-link.
You give some optimization away on at the switch evaluation.
I don't think so, because because when I say link, I mean codegen. That's when the actual
codegen on that guy. If you have, for a number of interesting cases, if I have a known value, I'm going to do things different.
Because when we link, though, that's where we have transitive closure across the type system.
Yes, but do you bring any code generation at link time?
Yes.
Oh, okay, fine.
So we're linking the IR as the basis to form a type system, which is the basis for the code gen.
Okay, and then you can optimize the code gen after that, which is fine.
Absolutely.
This is very similar to Java in terms of the compilation happening after.
Except there are a lot of things that can't be done symbolically.
You can't do it symbolically, yeah.
Right, and not a lot of respect. Well, until Java 9, I guess, for the modularity. Yeah.
Oh God. Someday I'll stare at Java modules. Right now, I'm just like, no, I don't.
It's a hard thing to retrofit to a system. So I think, the fact that it works at all is pretty amazing.
Yeah. So fine.
On that note.
Yeah, we can quit here. This has been an hour and a half. Is that what you're saying there, Cameron?
Well, yeah, I have to bail because my daughter's waiting for me to go skiing.
Okay.
But
tough life.
Very good to see y'all.
Yeah, it's fun. All right, till we meet again. Bye-bye.
Bye, everybody.